Now, in this hour, I would like to like kind of walk you through of the Tafang notebooks, right? You already work on that notebook for a couple of weeks already, right? So I simply walk you through and see if you have questions we can discuss, right? Now, this is a good, uh, well, this is the practice, right? When you switch project, uh, well, you want to like clear your environment, right? And you want to move to the project folder, right? It's the found project folder, right? Okay, and you want to set the project folder as your working directory, right? Okay, that's the preparation when you switch project. It will save you a lot of trouble. Okay, and then if you want to see the notebook, you actually can like just click and view in web browser. So because you already see this in a couple of weeks, so I will go faster, right? I told you already, right? The retail data is very straightforward, right? Okay. Usually this is the way, this data is kind of like generated on the POS machine. The POS machine is the machine that like you go to the retail store, and for every item you buy, you like go, you will be something, right? You like scan the barcode, right? But every time they scan the barcode, it will be a record generated. Okay, so this data is already in retail, like in before we have the barcode scanner, you know that it's very difficult to do data analysis. But the barcode, as soon as we have the barcode scanner, the entire marketing, the entire retail data is just coming to a different era, right? So that barcode scanner is very important up to this point of time. Steer the most important data, steer the most important business data that in the business environment. So usually, as I told you, that it is like one record per barcode scan, right? So, but in every shopping cart, there are a lot of items, right? Okay? So this is the item, and this is the cart, and this is the customer, right? A customer can, well, if you have a history data, a customer come to you many times. Every time they will buy different items, right, in an order. So before anything, you want to summarize the data by the unit of analysis. This sentence is very important, right? Okay, what is your subject of interest, right? What is your subject of research, right? You want to aggregate data into your research subject. Okay, if you are researching product, you want to aggregate data into a product item. If you are investigating product category, then you need to aggregate data into the product category. So you can compare them, right? Isn't it? Before you can do prediction, I mean, you want to explore the data and see what is the difference between different groups of product, between different groups of customer, between different categories of products, right? So you know that where your revenue come from, where your profit come from, isn't it? Right? This is all about data exploration, and don't overlook the importance of data exploration, right? Some of the quantitative courses, they put the entire or the most majority of the course on prediction and on modeling, right? But that is not a good way to do things in business analytics, okay? In business analytics, I think the right weight is to have like 50% of exploration for strategy, right? And then you will have 50% of modeling and prediction for tactic, for the how to do things, right? Now you have two steps of strategy, right? First thing is you want to know what to do, right? You want to set a goal, you want to know what to do, and that is exploration, right? And the second thing is, as long as you have a goal, as long as you have you know what you want to do, you need to do it, right? The how is what we want to cover in the second half of our course, okay? So let's take a look at this notebook, and just raise your hand, right? If you have question, okay? You have do this already, right? So we read in the data and put it on Z, and that is just my own personal my own personal habit, right? I always call the raw data as Z, right? that is important, right? If you do business analytics all the time, right, you have better has a convention, right? For me, I will always put like raw data as Z. I will name it Z, okay? So, and usually the Z data set is actually the item, right? It's the per item data, okay? Now, the second thing is like after you read in the data, you want to rename it, right? Okay? Because the original column name is like too lengthy, right? I told you, right? Use short name, otherwise you will get into a lot of trouble, especially for the beginner, right? And then now, the first thing after we get the data is to see how many data we have, right? Right? So it's very natural to see the number of rows, and then we want to do some data conversion, especially for day, right? We already learned that, right? Day, you need to like transfer. You need to convert it in the. Let me go into that. No. So as you read in the data, you will see that the day column is in character string, right? You want to convert the character string into the internal date data type, so you can do manipulation. Now, so after we convert into, as you can see that I do the conversion and put the result back to the same column, right? Okay, we don't need to create a new column, right? After we do the conversion, we just put it back, and then we can do the histogram. So you can see that this is a very short. This is a very short period of time, right? It was just like from October to like that end of no, to the end of February, February, right? Okay. We have some data in March, but I think it's only a little. And for some reason there's a break here. Okay. It's like it looks like Christmas, but in Taiwan we don't really have Christmas break, right? So it's quite strange. I don't know what happened here, right? But that's what happened. And there is a peak here, right? Looks like it is the Lunar New Year, right? It's in Taiwan, right? Okay. And we have age group, right? So we kind of, because in the original data the age group is look like this, and it's quite confusing. It's quite confusing. So we do some conversion, right? So you can see this, right? So this two chart, we can say that it's the age group distribution, and this chart is the area distribution of customer, right? Of the entire customer population, right? This is the age group distribution. What do we mean by distribution? Anyone still remember? Have we ever covered that? That's why I asked you the Professor Li Chen-Chen's course, right? What do we mean by distribution? We say that this is the age group distribution of our customer, right? What does that mean? What does it mean by distribution? Can anyone like define distribution in a sentence of natural language? What do we mean by distribution? Now, let me make it easier. So when we say distribution, we are talking about a distribution of a variable, right? Of a column of a variable, isn't it? Right? So when we say that this is the distribution of age group, right? What does it mean? How people are spread, right? Distribute across each different age group, isn't it? Is it clear, right? Okay. So what we mean by distribution, we want to see the count, the frequency, right? The count, the frequency that each of the value of the variable, right? So we want to see that, we want to count the numbers of each of these variables. If it was categorical, right? If it was categorical, we want to count the numbers of occurrence, right? For each value of this variable, right? I say it again, right? We're talking about distribution of a variable. Then we are talking about a variable varies, right? That's why we call it variable, right? It varies, right? So it varies, so you have different value, right? And we want to count the number of different values in this variable, right? We want to see the frequency of each of the value, right? We want to see and compare. Actually, this distribution has a sense of comparison, right? We can see that in the customer of this Tafang, in Tafang's customer, which age group have the most number of customer? We can see that, but A39, right? Isn't it? See that, right? So you can see that the middle age is the major customer of this retail store, isn't it? We want to see the distribution, so we see that as a whole, right? you can see a global structure of your customer, right? And you can describe your age of your customer this way, right? Instead of giving you the average number, right? This is much, much better than just looking at the average age, right? Because you actually see how the age, right, distribute on each domain, right? The same thing, this is area, right? So most of the people are living in 115 and 221, right? So it's 115, which is Nangang, and 221, which is Xizi, right? Okay. Most of the customer come from these two area. Okay. And we have some. See here we have A99. It's not really A99. It's like kind of like NA, right? It's not missing value, right? Okay. And here we have like others. The others mean that it looks like this data is for their member. So if you have member card, so you know where this customer live, right? So in this category is that the people that live other than this zip code, right? It's live outside. I know where he live, but it's not here, right? And this thing is like unknown, which means I don't have idea of where he live, right? So that's different. That's the difference between the two, okay? Then I'm handling this outliers, right? Do you know what is outlier? You know it, right? You know it, right? Do you want to like define what is outlier? Yeah. It's not the minimum or maximum idea. It is like there are some out of group data, right? Most of the majority of data is here, but we have something here and something here, right? That's what we call outlier. Usually this is not a normal customer, right? See, right? If you have like if you see the summary of like if I do this, you see that most of the people are buying things like, right? The quantity is like less than 50, I guess, right? But there are someone like buying something like 100 and 200. These people is not what we want to do, what we want to analyze, right? If we put these people in our data, it would destroy the most of our analysis, right? You make this chart very ugly, first of all, right? Okay, so that's why we need to deal with this outlier, right? And the way we deal with outlier is, can you understand this code? Well, in this code, I actually try to find out because for business data, especially for quantity, for cost, for price, right? These things, the outlier is in the right tail, right? Because the on the left side is always bounded by 0, right? Okay, so you don't need to worry about the outlier in the left side, right? It's bounded by 0 already. So in these three things, I calculate the 99 percentile, right? I calculate 99.9 and 99.95 percentile of each of this variable, right? Which means that only only 1%, right? Only 1% of the items has a price more than 1,000, right? Only 1%, and only 0.1% is more than this figure, right? And only 0.5% is more than 4,000, right? So we can say that if the item is more than 4,000, maybe the item is like out of our consideration, right? So so we can remove them, right? We can remove them, yeah, just to make our data easier to interpret, right?
But like for this point, like we have to just make the adjustment.
Yeah, you just make your subjective judgment,
So
right?
it's like they have no the most appropriate is like 99%, 99.5. We cannot complete. We just look at it.
Yeah, you don't know which one is better,
We have
but
to
you just want to make a decision. On the one hand, you don't want to cut too low, right? You cut it too low, you will lose maybe important customer, right? But on the other hand, you don't want to let this like true outlier influence your analysis, isn't it? Right? Okay. So if you are doing regression, this outlier has a very serious impact on your predicting analysis, right? So we better like exclude them before proceeding. All right, so after clearing the Z data set, which is the data item, now we start to, I told you, right, we need to aggregate item into transaction orders, right? And to do that, we now first of all, this data set has a very strange things, right? Usually, this post data would have a order ID or transaction. It should have a column called order ID or transaction ID, right? But this data set, it do not have this data. It do not have this column. So we do not have a key to aggregate the transaction, okay? So the way I solve it is like I actually create a new variable called transaction ID, right? And this function called group index, which means that like for every unique combination of data and customer, I will create a unique ID for it. Which means that all of the item that a customer buy in the same day, we will treat it as a transaction. So it's not likely that you go to a grocery store like more than one time a day, right? It's not likely that, right? So even it's the case, it's still appropriate to like treat it like a transaction, isn't it? Right? So so I just like make this up, right? Okay. So we have a new column of TID added into this Z. And then, sorry. So there's a warning, but I think you don't need to worry about that, okay?
For this function, the group indices, they will they will group the same like the day customer.
Yes, yes, yes. Because what it does is actually for every distinctive combination of day and customer, okay? For every distinctive combination of date and customer. It will create a unique ID, right? So for each ID, it would definitely have a different customer or date. You see what I mean? Okay, that's what I mean by group index, right? You want to generate a group index based on these two variables, or specifically based on the combination of these two variables, okay? So we actually do this, right? We just send a GIF. I tried to send a GIF a few times, but it didn't go out yet. What does it mean? So this is the data frame, right? Okay. I pick up a few columns in this data frame, okay, and I put them in the sapply and apply this n-distinct function, okay? So, which means I apply n-distinct to each of this column, okay? So what does it mean? What does this number mean? When I apply n-distinct to customer, what does the number mean? Sorry?
The number of customers.
Yeah, the number of distinct customer in this data set, right? Right? Because this n-distinct function, they are counting the, right? They are counting the number of distinct value in that column, right? So in this data set, we are talking about 32,000 customer, 2,000 product category, okay? 23,000 product item, and like 119,000 transaction, right? Okay. We can see that we have like 7,000 items, right, in this many transactions. So in average, every transaction have something like less than 8, right? 7 items also, right? So this is not a convenience store, right? Okay. In convenience store, like the average item would be less than that, right? So actually, this is not convenience store. Okay? You can see that this is kind of like grocery store. Okay. So now I do the group summary, right? So as you can see that if you have the sense of business, for every transaction, you have a lot of things that you would like to know, right? What is the date? Who is the customer? Now, what is the age group and area of this customer, right? Okay. And then the number of items in that transaction. So after we group by transaction ID, every row, right, is a transaction. See that? Right? This is the number of transactions, right? And this is the number of row. This is the number of record in X, right? So my convention is I put transaction as capital X, right? Now, so we like this is the number of items. This is the number of pieces, the total amount, and what is this? The gross profit, right? Gross profit. So after this aggregation, we will do the outlier handling again, right? Okay. You will see that some customer like it's generating a lot of or buying a lot of money, right? So for example, like usually you will do a summary and you will see that price is okay, and but this is not okay, right? Because the total, the mean of total is like less than 1,000, right? But the maximum is like, see, the third quarter is 1,000, but there are some transactions more than like 10,000, right? So these are the third quarter is 169, but the maximum profit is like this, okay? So there are some abnormal, there are some irregular item in the transaction label. They also need to be filled out. And that's what we are doing here and here, right? We sacrifice, we cut out so we can do the, then we do the summary then, right? So it's fine now. And then now you can see the number of transaction per week, right? Okay. And then now we can do customer, right? Now we want to aggregate transaction into customer. Now before doing that, I do this, right? Usually we would like to know how long. What is the last time that this customer come to us? We want to know how long he have not come to us, right? This is what we mean by recency, right? Because the longer the customer did not come back, the less likely that he will come back again, isn't it, right? So how long that, what is the last time that he come to us, right? The period is important. We call it recency. So in marketing, we would always like to, per customer, we would like to know a few things, right? First thing is the recency. I think this is wrong, right? Oh, okay. So as you can see that I mutate a new number called days, right? The days is actually the days since the last time this customer come to us, right? So let me say it again. Days is the number of days that since this customer last come to us, okay? So that is important, right? So if the day is like 7 days, it means that 7 days ago is the last time this customer come to us, right? If it was like in this data set, because the period is short, right? So we cannot, it did not tell too much. But when you are seeing a long-term data, you will see some customer has not come to you like 3 year, 4 year, maybe 5 year, right? That type of customer is already like gone, isn't it, right? But in this data set, because our period is short, so this R and S does not mean too much, right? And then frequency is the number of time that he buy from us. Monetary is the average amount that every time when he buy from us, right, is average amount. And this is the total revenue contribution, the total gross profit, right? The age group of this person, the area code of this person, right? Okay. So you see that, right? From the raw data to transaction to customer. Now you have this number of customer, right? Oh, sorry, I have not do this. Okay, so now we can see the distribution of customer. and then we can see the distribution of RFMS, right? As I told you that F is easier to understand, right? F is the number of time the customer buy from us, okay? Let's go to here, it's easier to see. So this is the distribution of F. F stands for frequency, which means the number of time a customer buy from us. So the most frequent customer buy from us like 85 times, right? But most of the customer buy from us in less than 10 times, because we only have 4 months of data, right? Okay, so most of our consumer buy from us at one time, like less than 10 times, right? Okay, so if your data is like this, sometimes you want to like do a p-minimum on this column, right? This is one of the technique to treat this. We call that this distribution skew, right? Skew to the right, right? Okay, it's very heavily skewed. So one way to treat this skewed data number is kind of like apply a p-minimum. P-minimum of 10 is like everything more than 10 is counted as 10, okay, right? So you will see the distributing, like, this is to emphasize the distribution between 1 and 10, right? So this is one way to visualize the frequency of heavily skewed, okay? And the other way to treat this this is money, right? The average buying amount. So this average buying amount, we can apply log. You see that? Okay. So if you apply log 10, usually in business we will apply log in 10 base. So I know that this is 10, right? So almost no people is buying less than $10, right? 2 in log 10 means 100, right? Okay. So only very few people is buying like less than 100, okay, in average. But most of the people is buying like, right? You see that the distribution is here, right? It's around 3, right? Log 10 3, which means that 1,000, right? Most of the people, most of our customer, like when they come to us, their average buying amount is around like 1,000, right? Okay, so this is the way to handle this skewed distribution, right? So now you have a point, right? Why distribution is important? Let us see your situation, right? See your global situation in the graph, right? Okay. So here is actually just like after the processing, we want to check that if they are missing data, right? So if they are missing data, you will see the number here, but the data is very clean. We do not have any missing data here, right? So after the processing, this is the very good practice, right? Set the data that you have, right? So you don't need to like run through this notebook time after time after time, right? Next time when you want to see this A, Z, and X after cleanup, right? You simply load this R data, right? So aggregate, clean up, and then set the data. This is the purpose of the first notebook, okay? Any question about this notebook? Okay. Well, so at the end of the first notebook, I actually have a list of like, I should say example exploring question, right? So explore, as I told you, they do not have a fixed objective or fixed or specific objective there. You look into the data to see what you can see, right? Okay, but although we only have one data frame, right? But with this data frame, this is other thing that you can find out. Right? Okay. If you are with the technique that we have learned so far, I mean from week 1 to here, right? If you still remember what I have told you in this course, these are the things that you can answer simply by the post data, right? Okay, so but these are the things that I mean, this is to get you started, right? Okay, just think about that. And when you explore the data in this way, you might see something interesting, right? Okay, then you want to dig in, right? Isn't it? Right? That's what I mean by exploration. Okay, so this is not the goal, and and this is not the complete list. Okay. Okay, it's just some example to get you started with your exploration. Okay, any question about this these things? For example, if you want to define group of customer in different ways, right? For now, you can actually segment customer by age, right? You can segment customer by their area, right? And you can also separate customer by the product that they buy, right? Okay, you can actually segment data by are they a weekend buyer or they are a weekday buyer, right? They are two different groups, right? Isn't it? Okay, so there are many different ways to do customer segmentation, and after you segment them, you should know their characteristic and compare the characteristic, isn't it? Right? So it's always this aggregate, grouping, compare. You're doing this repeatedly in this period, right? And that is what we cover in the second notebook. We don't have time to go through the entire notebook 2. I only have time to. We will continue. We will go back to this one. Don't worry. Okay. Next week. I intentionally slow down the progress because I want to make sure that like everyone can catch up, right? Okay. This is the first time I apply this on this IB, but you can tell us if I'm going too slow. You already fill up the questionnaire, right? So I'll take a look at that questionnaire and see what we need to adjust. Okay. So this T2 exploration is like using plot, right? To see a global structure, global trend, global phenomenon in the data. So this is the edge group and also the area distribution, right? So what is this? This is something that need to explain, right? This chart I have not told you yet, right? But what does it mean? Okay. Now, we say that this is the distribution of edge group, the distribution of area, right? And this chart is actually the joint distribution of area and edge. Okay? let me say it again, right? This is the distribution of age, distribution of area. We know that it is useful, right? Because by looking into the distribution, we know the structure, right? The global structure. Now, this is the one variable. This is the second variable. They are two different categorical variable, right? Okay. So, but if from time to time, if we put two categorical variables together, we can plot their joint distribution, okay? The joint distribution is kind of like a table, right? You can do a table out of it. Let me do that. So the two histogram is actually, sorry, I have not loaded the data yet. Okay. So this bar plot is actually right? This bar plot is actually to visualize this table, right? Isn't it? It's one-dimensional table, right? But how about a two-dimensional table? I mean, there are two questions. First of all, if I do table like A of H, let me see, area, and A of H, or A0. I will see a table like this, right? Isn't it? Right? So if I can see the so this is actually the joint distribution, right? This table actually is the joint distribution of these two variables, right? And this plot is actually the visualization of that table, okay? It's actually the visualization of that two-dimensional table. Now, the way to look at this chart is like the size of each box, okay, represent the number in the table, okay? You have a table like this, right? You have a table like this, right? So each of the box, the box size actually reflect the number here, okay? So so the box size is easy to understand, right? Okay? And because I put area here, right? So the height of area is exactly the same as this distribution, right? As you will see that the highest area is the 115, right? And the second highest is 221. So in this direction, as you can see that the horizontal divider is like kind of like separate the boxes, right? So so the height of the area actually reflect this one, right? But because the thing that the horizontal separator, they are not aligned together, right? They are like bouncing left and right, right? It's because that in each of this area, they have different distribution of age, right? Right? Because like, let's take this this column as an example, right? And this column actually reflect, because Z115, right? So this column actually reflect the box size actually reflect this column. Okay, the box size actually reflects this column, right? So okay, so besides the size, it also has a color, right? Now, what you really need to know is what the color means. Okay, okay. The red color means that compared to the population, compared to the common age group distribution, the red color means that in this area, the age group 34 and 39 is lower than the fraction of A39 and A34 in area Z115 is significantly, the color means significant, right? Significantly less than the common distribution. Okay? The color actually means that less than or more than the common distribution. By common distribution, I mean that if I do not consider area, right, I simply do a age group distribution. This is the population distribution, isn't it? The age group population, we use this age group population as our benchmark, right? As our benchmark. And we want to see that in each of this area, right? In each of this area, we want to see that the age group distribution of this area is that less than or more than the common distribution, right? Okay, that's what we want to know. So from this, we know that, well, relatively, we can say that, relatively, there are fewer 34 and 39 customer in Z115, right? Okay, significantly, statistically significantly, the proportion of A39 and A34 in Z115 is significantly less than the common distribution, right? So at the same time, we can say that in 221 and Z others, right? You can see that, right? They are in blue color, so they are significantly larger, right? They are significantly more A35 and 39 in Z221 and Z others than the common, right? Okay, this is very important to marketer, right? Because not only that you want to know the one variable distribution, right? You want to know that, actually you have different, age group distribution in different area, right? For some reason, right? In Nangang, your customer distribution has more age group and more younger group, right? Okay, and for some reason that in Xizhi, right, your customer has a larger distribution in A39, A29, 34, 39, and they have fewer elderly in Z221, right? So this is important, right? Okay. What's even more important is if you apply this to say this is the age group and this is the product category, right? So you can see that, right? For each different product category, right? Their age group distribution are very different. You see that? Which means that different age group prefer to buy different product category, right? As a marketer, this is what you want to learn, right? Okay? And here, as you can see that I put this. What does it mean? This is age group, and this is weekday. Okay. So this joint distribution tell us that. Can you tell me what this joint distribution tell us? Yeah, young people and elderly, right? They don't they tend to buy it in the weekdays, right? Okay, comparing to right, it's relatively comparison, right? So as you can see that these two boxes is very important, right? Because they are big and they are significantly higher, right? What does these two box mean? These two age group, right? Okay, they like to do shopping in Sunday, right? Okay, right? Okay. So this is important to marketer, right? You want to know when you have the chart of this mosaic plot to help you to do the joint distribution for more than one categorical variable, right? Okay. So this is the thing that I haven't told you before, and what you need to do is sorry, this is 12:08 already. Sorry, let me do the assignment. I think you are not ready for the assignment for Unit 7 yet, right? Okay. So what you need to do is like apply the ggplot, right? The ggplot technique. See in notebook TF2, I do not use ggplot, right? I use a little actually. Okay. but now you learn a lot about ggplot already, right? So you want to from the global phenomenon, right? If you see something that is impactful for the retailing business, right? You can use ggplot to do to dig in, right? To develop the dips of your analysis by using dplyr and ggplot, right? This week's group assignment, I would like you to apply ggplot and let me see, it should be here. Don't do this individual assignment yet, right? Because we don't. I will modify it, but the group assignment is to apply ggplot to the Tafan, dplyr and Tafan. Sorry, dplyr and ggplot to Tafan, and then make an HTML and upload to your group folder. Okay, so no personal assignment. You only have the group assignment. Is to apply dplyr and ggplot to. Okay. Okay, so that's all for this week. We have 10 minutes delay. Sorry for that. So that's all for today. I will see you next week. Okay. Or maybe I'll see you in the TA session, right? Okay. So get together, right? Get together and start to do the exploration, because 2 weeks from now you will need to submit your midterm report, right?